Hello, everyone. Some logistics first. You might want to turn off the bell and the notifications on the top of the screen in order to avoid nasty sounds. So yeah, welcome everyone to the Renderman Art and Science Fair 2020. My name is Oliver Meisberg. I'm the Vice President for the Renderman Group here at Pixar. As we all learned, 2020 is a very different year, and so are we. Everything's going virtual. And so we decided to also make a virtual event, and we want to make it slightly different this year than what you usually know from our SIGGRAPH events. So instead of doing like one big event, we decided to go for a 3-day event. And today will be all about RenderMan 24, and then the coming days will be more deep dive sessions, what 24 is all about, and I give a little bit of an overview in a second. So the team has worked really hard to on RenderMan 24 and make it an awesome release. And one thing I can tell you, RenderMan 24 is not just a standard release. It's one of the biggest ones that we ever ship. And I want to thank my team for really putting all the hard work into this release. It's going to be a fantastic one, and you will find out in a couple of minutes. But let's talk about what you can expect from today and the coming days. So today, the event is mainly about the presentations and RenderMan 24, and then we will have a Q&A panel at the end where we allow some questions, and we have some experts from the group and also from the Studio Tools team to talk about various questions. Tomorrow, we have deep dive sessions where we go into what's new in RenderMan 24. And that starts at 9 a.m. and then we go a little bit into detail around Renderman Xpu at 10 a.m. And this will be a joint session with Alec Barch from production at Pixar to give you a little bit of an insight how we use it at the studio. At 11 a.m. we have a new production shading course that Philippe's going to present, and you will find out what this is all about also in a couple of minutes. And then we close the day tomorrow with a great panel discussion about women in RenderMan, hosted by a lovely Sarah Geimer, our senior technical recruiter at Pixar. On Thursday, we want to give you an update about an upcoming challenge and a new training material that we're going to launch soon. And then the title says New Bridge Tool Reveal. I'm not going to talk what it's all about yet. You will find out in a couple of minutes. And then we changed the title accordingly. And then you might have seen the Renderman Stylized Looks, so we haven't really talked about it that much, but there's a few presentations out there already, and we will give you a deep dive of what this is all about, and it's a fantastic release. And again, we close the day off with RenderMan 24 for TDs, so it's a little bit more of a technical deep dive, how you can use RenderMan in production. I also want to thank our partners, the Foundry and Side Effects Software, for supporting this event. And then, without further ado, I will introduce or welcome Dylan Sisson to this virtual stage to give you the great presentation of RenderMan 24. Dylan.
Thanks, Oliver. Hey, everybody. This is a different kind of science fair this year. I can't guarantee it's going to be the best science fair ever, but it's going to be the zoomiest and maybe the best, who knows. Before we get started, we've had a lot of questions come in about, are we going to do a teapot this year? And I have to say, well, we couldn't say no. So we have a little teapot reveal for you this year, and I will show you in our big reveal. So here's a big reveal called the Big Reveal, and I'll start playing this. If you like it, please comment positively in the chat box. If you don't like it, the chat box is Well, I hope you're happy. That's the best we could do, and it's kind of a historic thing because I think it's the first AR swag ever, and if not, it's the best AR swag ever. So um, that is clear. Let me bring up my deck of slides and get started telling you a little bit more about what we have in store this year. We'd like to thank our pals in the USD group and at Apple. The Teapot will be made available as USDZ, so you can load it into your iPhone and have a lot of AR fun with it. And there's a little URL. You can go download that now. And it gets better because some of our partners in the industry, the Foundry and Side Effects, have spiced things up by giving us some awards. So we have 3 commercial RenderMan licenses, 1 Katana license, 1 Mari license, and 1 Houdini FX license to the most liked post on Instagram by Friday, September 4th at noon. That's high noon for you you folks out there. So you must post it with the hashtags RenderMan and hashtag Walking Teapot. And if you forget, you can look at the bottom of the teapot. It has the hashtags on it that you need to post. And I wanted to point out that I actually baked these words onto the bottom of the feet using light baking, which was released in RenderMan 23.3, sort of from the Department of Stupid RenderMan Trickery. So instead of going back to Substance, putting the textures on there, exporting the textures again, I just put lights underneath the feet and shown the text onto the feet and then bake that lighting out. So lots of cool new features already that you can use in RenderMan. Some of the other things that are cool in RenderMan this week are new educational materials. So if you want to be learning more about RenderMan or teaching people that are coming on board about RenderMan, we have new training from Eugene Rakansky. He's a creative director in London. He's worked on a lot of music videos and has a really interesting angle on the educational materials. They're available soon, maybe even now, but at least by Thursday, you'll be able to check them out. And we're having a talk on Thursday at 9 a.m. So come join us and check that out. We also have on Thursday during the same talk, a reveal of our new Next to RenderMan Art Challenge. This is our 7th Art Challenge. We have a lot of great sponsors. So if you win, you can get a lot of prizes and you can impress your friends. If you don't have any friends, you have no reason not to join the RenderMan Challenge. And you don't need to buy anything. You can use non-commercial RenderMan. So that's a great excuse to use non-commercial RenderMan. As I like to say, it's not going to try itself. So that brings us into the main part of the show, which is our preview of RenderMan 24. And just to kind of set the context and set everyone's expectations about this release, I have a roadmap. So we're announcing now, and we're going to be rolling into beta for R24 in early December. And so all the good stuff we'll be covering really quickly will start coming in early December. Then we're going to have a final release in Q1 of the next year, 2021, if you can believe that. That's going to be between February, March, or April, and January if we get really lucky. But that's kind of the context of how this is all coming down the pipe. First of all, R24 plays well with others. We have advancements in all the DCCs. We're working closely with our partners at Foundry, Side Effects, and Autodesk, and we're supporting all the new features in Katana 4.0, like all the new lighting features that are great. Houdini 18.5, Solaris is going to be supporting LPEs and ALVs, and Maya is going to be supporting all the new features in 24 as well. If you want to know more about that, we have a talk called What's New in RenderMan 24, and that's tomorrow at 9 a.m. So you can check that out there. And I don't have a drum kit, but we could do a drum roll. So just think about a drum roll. And there's more. Plays more with others in a good way, not a creepy way. RenderMan 24 is also going to be supporting Blender. So we have a new bridge tool reveal on September 3rd, where Ian Shui is going to show everybody his work that he's been doing on the Renderman for Blender plugin. I saw his presentation. Is actually excellent. It's a great implementation. So we're pretty excited about getting that out there in R24. And we have better tech as well. So we have ACES support, OCIO out of box. So that's great. You know, if you want to expand your color gamut, and who doesn't, it's a great way to bring more fidelity to your images. We have real-time statistics. So in the world of always on rendering, you have all this kind of interactive rendering. Now you can turn statistics on at the same time. So you can have your model here, slap a complex shader on it, and see immediately what kind of impact that shader has on your scene, or load in a piece of geometry and see you know, the impact immediately of that action on your scene. So it really gives you a high level of transparency into what's going on. Blue noise sampling, for people that are into that stuff, provides a clearer perception of what the pixels are going to be doing earlier, so you can sample less and get earlier previews for IPR. We have new patterns, so we have phaser noise, which is stunning. We have hex tiling, which in the good way. So we have a nice way of making non-repeating textures, and unified bump map. So that's lots of good stuff. That's going to be in Renderman 24 for TDs, and that's on September 3rd at 12 p.m. And we're moving all of our nodes over to all of our patterns to OSL. So that's going to just make everything much simpler in a number of ways. So we're excited about that better tech. But most of all, they said it wasn't possible, but Renderman 24 is now even better looking. We have Xpu, Stylized Looks, and Llama coming online. And let's talk a little bit about those. Xpu, we're announcing, we've talked about Xpu before, but this is the first time we've announced a release for it. So you'll be able to get your hands on it in December. And right now it's being rolled out at Pixar as a look development tool in our look development tool at Pixar Flow. And it has a strong feature set for look development. And they're doing a lot of testing. Alec Barsh is going to be talking about that during the Advances in Renderman Xpu session tomorrow at 10 a.m. And here's an actual Pixar asset being shaded in Xpu and Flow. So that's kind of a groundbreaking kind of watermark for Xpu. And looking at it in this sense, we're going to find Xpu coming to the DCCs, our external products, with a look development feature set. So it's going to be geared for look development. Mark will talk about this a little bit later, but it's not going to support things like volumes, but it's going to be feature complete for doing look development on your assets in production. So we're excited about that. And we have Stylized Looks. So Stylized Looks in RenderMan are coming, and these are interesting because, as we talked about always on rendering, these aren't like a post-process. They're not a bunch of AOVs that we're putting together in a compositor. They're actually being put together upstream so we can run IPR on these different types of looks. And you can see that we can get different types of lines based on lighting. We can break them up a little bit. We can color lines by albedo or by the lighting in the scene, and just do a lot of cool stuff. So we'll be talking about that, or I will, on September 3rd at 11 a.m. and breaking down some of these shots like this. So we have kind of this treatment over on the left that I've worked on, and we'll also have Ernst Grossbeck talking about the treatment on the right. So we'll be breaking down some case studies and telling you a little bit more how this process works. And finally, we have Llama, which are layered materials. This has been technology was developed at ILM, and it's node-based, load-based, so you can kind of mix and match your shaders and put them together in efficient ways. And it has a lot of interesting features that our next speaker will be talking about. And we're really excited about it. There's going to be a whole session about this on September 2nd, tomorrow at 11 a.m. But without further ado, I would like to bring on Philip Blueprints. And I don't always use the words super and genius in the same sentence, but I do during the Renderman Art and Science Fair when I am introducing Philip Blueprints. He's been doing some amazing work with our tools, and please welcome our super genius, Philip Blueprints.
Hello. We are going to talk a bit about Llama. Let's switch to the right thing. Here we go. Okay, so this represents the new generation of materials for RenderMan. Llama stands for layered material. It was developed at Industrial Light and Magic to replace their previous solution, monolithic BXDF with a prearranged combination of lobes, similar to Pixar surface. The main idea was to separate the lobes to create arbitrary combination and make it easier to add new lobes whenever necessary. Llama is a node-based system with a small number of user-friendly nodes. It is currently implemented in RenderMan RS and Mari and has become a production-proven tool at ILM. In Llama, you will find 3 types of nodes. The main BXDF that will be attached to your object. It renders nothing but by itself, but controls the other connected Llama nodes. The layering nodes allow you to combine 2 lobes to build your material's final appearance. The BSDF nodes are the lobes that will respond to your scene's illumination. And this is what Llama material looks like, a node graph. The highlighted nodes in the image are Llama nodes. The other nodes are regular patterns. In this case, we first combine a diffuse and a dielectric lobe to create a shiny plastic, and then combine the result to add a layer of diffuse dust on top. In Pixar surface, the diffuse lobe is at the bottom of the stack. In this example, it is at the top. Llama brings a new level of flexibility in that area. But let's take a look at the main BXDF, Llama surface. So Llama surface has only a few settings to control downstream nodes. It sets up the material per side, controls the execution of some features like opacity, presence, and triggers custom AOV evaluations. Let's take a look at the material setup. So by default, we have a single side material. In this case, the number of active sides is set to 1, and a simple diffuse node is connected to the front material plug. Now, if I set the number of sides to 2, the same diffuse material will be used by the backside. But I can also connect a different lobe to the back material plug. In this case, it's just a conductor node, but you can, of course, have a full graph for each side. So what has Llama to offer? Quite a bit. First off, you get 9 different lobes to build anything you need, from hard surface to hair and fur. Then you have 2 ways of combining these lobes, horizontally and vertically. To give you a better sense of how much is available, let's take a look at each node. Llama Conductor is designed to create metallic surfaces. It has the usual controls like Fresnel, anisotropy, iridescence, as well as a couple of new features, full energy conservation and GGX tail control. Let's dive in. Our previous BXDF, Pixar surface included, specular lobes suffered from energy loss at high roughness. The Llama nodes implement microfacet multiple scattering using Emmanuel Turquin's technique. The result is perfect and fast. It is used by all specular lobes as well as the diffuse node, as the RNIR algorithm suffers from a similar energy loss at high roughness. In the RNIR case, the algorithm has been tweaked to avoid oversaturating the colors, which is problematic when your albedo texture has been painted from a reference. Now, let's move to the other new feature, the Specular Easiness or tail control. It is a way to create a halo around a sharp specular response. This is often visible on metals or shiny dielectrics with micro scratches. In the past, artists often had to combine two specular lobes to achieve that effect and increased render time. This system combines two roughness values into a single specular lobe at a minimal cost. It has the same looks as the GTR lobe used by the Disney BRDF's clear coat, although the GTR lobe cannot be tweaked and it's a lot more flexible. So let's go back to our nodes now. Next one is Lama Dietrich, which can be used for glass varnishes, coatings, and so on. Energy conservation is a great improvement for frosted glass, of course. It includes the usual controls as well as a long-awaited new feature, dispersion. This will make quite a few people happy, I'm sure. Note that Lama Dietrich offers more granular shadowing control than our previous offering. Lama Diffuse is your classic RNIR node with better energy conservation. Also note that in many Lama nodes, the energy compensation slider allows you to tweak the look to match older assets that were not energy conserving. So you can move your old assets to this new system if you want to. Lama emission, as usual, this is for low intensity emission like small LED screens. Pushing the incandescence values will introduce noise, of course, as it cannot be sampled as efficiently as regular light sources. Lama's subsurface scattering handles all subsurface scattering duties, strangely enough. It implements both of our past traced subsurface algorithms, as well as the Burley algorithm for a different look. Sheen is used for cloth, speech furs, and other microfiber scattering effects. This lobe is energy conserving, whereas Pixar surfaces wasn't really. Lama Translucent is evaluating back-facing diffuse illumination. It is typically used for tree leaves, paper, and thin cloth. It is a separate node to make double-sided materials more controllable and also potentially output to a different AOV. Lama Tricolor Subsurface Scattering is another subsurface scattering node. This mode was introduced in RenderMan 20, and ILM liked its versatility. They found it was useful to use tricolor SSS in some areas of a model and use Lama SSS in the other areas and blend them together. That is one of the big advantages of this framework, the ability to blend different subsurface scattering models in the same material. It wasn't possible before. Lama Hair Chiang implements the Chiang hair model, which has been very successfully used by Walt Disney Animation, Pixar, and ILM. It is energy conserving, efficient, and easy to control, reproducing a wide range of hair and fur with just a few intuitive parameters. Lama Mix is our first layering node. This is a horizontal layering node, which means that it blends two lobes a bit the same way as you would blend two images. It is similar to the way you can blend multiple Pixar layer surface nodes. There are two modes, normalized, which makes sure that the resulting blend is still energy conserving, and additive, which lets you go crazy at your own risk, of course. Mstack is a vertical layering node. It means that we have a layer on top of a base material. If the top layer is transmissive, Mstack can compute volumetric effects like absorption based on the top layer's thickness. This is a more physical way to combine two materials. To conclude this presentation, let's talk about ILM's experience with Lama. Look Dev artists quickly adopted the new system as it offers unprecedented flexibility. It also opens interesting possibilities to optimize some materials, but more on that another time. Performance has been great across the board, although one could imagine less skilled artists piling on lobes for no reason and significantly slowing the renderer. But in practice, with the same number of active lobes, performance is the same as a monolithic BXDF. Finally, ILM reconstructed their previous monolithic BXDFs with Llama to reuse all the assets. This technique can, of course, be used to support other models like Disney's BSDF or Autodesk's standard surface. So Llama will be available in RenderMan 24.0 in Houdini, Katana, Maya, and Blender. We are actively working with ILM to improve and extend Llama for later releases. After 24, we will implement Llama-based material exchange via Materialx and USD. And of course, Llama will come to Xpu as it represents for us the future of material creation. So thank you very much for your attention, and I will pass the mic to Mark Bannister, our lead engineer for Xpu.
Thank you, Philippe. Let me just get my presentation up. Hello everyone, my name's Mark Bannister. I'm the engineering lead for RenderMan Xpu, which is the new renderer being developed by the RenderMan group. I'll start off with describing what Xpu is. Some of you might not have seen previous presentations on this. It's initially supposed to be an interactive renderer. It's heterogeneous, meaning that it can support, or it's designed to support multiple bits of hardware. Currently, there's an implementation for CPUs and GPUs, but the design is to allow for any hardware coming in the future, ideally. A key design goal of Xpu is that it's going to be predictive of RAS, and it forms part of the RenderMan products suite in 24. Another key goal for the Xpu team is to make it easy to switch between RAS and Xpu. And actually, a recent piece of technology is a new interface that we have for both renderers, RAS and Xpu, called Riley. And the two renderers implement this interface, and that makes it easier for tools upstream to use both RAS and Xpu. And that's been key for us, is to leverage this new piece of technology. So Xpu at the studio, this has been a long time in coming, really. It's been a long road for the Xpu team to get here, but we've finally got our first production use case, and that is being integrated into a tool called Flow. Dylan's touched on this a bit before. This is a significant milestone. We've been developing Xpu for a long time, so we're really excited that it's finally being used in production. But by being used in production, it will inevitably encourage us to improve the software quality. That Xpu needs to be robust and performant for production's needs, and we're also treating this as a stepping stone for an external release. So the feedback coming from the studio will help us improve the software to the extent that we can release this more widely, and that should be coming up. So before I talk about the bits of software involved, I'm going to touch on how we integrate Xpu into tools. We have, as part of RenderMan 24, a USD Hydra delegate that is written for this new interface called Riley. And as a consequence of that, the Hydra delegate naturally can use either RAS or Xpu. We can seamlessly change the renderer behind the hood, and the Hydra delegate will still be able to render using any renderer that we produce as part of RenderMan. And that means that any tool that uses USD and Hydra, and a good example of this is Solaris within Houdini, can use both RAS and Xpu through the Hydra delegate, and that's the sort of software stack we've aimed for. As well as Houdini, Flow at the studio is written to use USD and Hydra, and consequently they automatically get both RAS and Xpu inside Flow. So moving on to what is Flow. Flow is predominantly really a shader authoring tool, a shader and material authoring tool. It's been used at the studio for quite some time now, for a number of films, including Onwards, Coco and Toy Story 4. It has, up until this point, been based on an existing GPU renderer called RTP, which is a renderer that was written by the studio. The renderer is based on optics. A key point about this renderer is that it has totally separate implementations for the BXDFs and the shaders that RAS provides. So for each shader in BXDF that RAS has, the team that developed RTP had to go away and write the same shaders in BXDFs for RTP. Well, you might ask, why are we replacing RTP? It has been an incredibly successful renderer for the studio. It's really great, and there's not a lot wrong with it. The pressure really is related to the ongoing maintenance. I touched on this in the previous slide, because there's separate implementations for everything. As RAS mutates and adds new BXDS or light transport features, or adds new pattern shaders, then RTP has to change as well, and that requires time. That requires someone to sit down and make sure that they match again. Despite all the effort that's gone into RTP to make it match RAS as closely as possible, it isn't a perfect match in all cases. There's in addition to that, features that are missing. And fixing the issues and introducing new features, it just takes manpower as well, and that makes it difficult to maintain going forward long term anyway. So why is this good for Flow? Why is having XPU in Flow a good thing? Touched on the reduced maintenance burden. That's really key. Frees up a team to do some production related tasks, which is great for them. XPU is developed by the RenderMan team, and the RenderMan team also produces RAS, so we can make sure that the two renderers agree on the final frame, and it's easier to ensure this consistency on the same team. There's also some benefits to XPU. XPU can use the CPUs alone. It can also use the GPUs alone if you configure it that way, but a key point is that you can use both at once. And there are some shots and scenes that the GPU struggles with more than others. For example, subsurface scattering, path traced subsurface scattering is a good example of this, and the GPU can struggle a little bit. And in these scenarios, you can have the CPU helping out with the same image, giving you improved performance on those scenes. So that's why it's good for Flow. Why is it good for XPU? First production use case, as I said, really exciting. The Flow team will feed back and help us develop or focus the efforts on where it's really important in XPU in terms of delivering frames for production. The focus is going to be on really quick, slick material and shader edits. So you can imagine sliders and shader parameter changes, and seeing the result of those in an interactive viewport. But in addition to that, we obviously need decent interactive viewport tumbling so that you can go in and inspect all of your assets. A lot of these images in these presentations has been produced by XPU. Some of them in Flow, some not. And so you can see the quality matches the quality that RAS produces. We still have more work to do. We're not there yet. We have already completed the first milestone for delivering XPU into the studio, but we still need to improve the responsiveness to edits, and we still need to improve the interactivity in certain areas. We're always we're stumbling on new areas to fix and optimize to improve the workflow. And the feedback from the studio is really critical for us. We need as much of this as possible to help focus our efforts on the right things. to make the product really robust and useful for a wider group of people. There's been less emphasis on final frame rendering as a result of XPU being used in Flow. So that's great if you're working at Pixar and you can use Flow, but what about everybody else? We're going to support Xpu in all of our DCC apps, our standard DCC apps, Maya, Katana, and Houdini. Houdini uses USD, so we use the same mechanics as for Flow to support Xpu. Maya and Katana use something called the scene graph, which also uses our shared interface Riley, so we can swap in and out RIS and Xpu in those bridge tools as well. So the future of Xpu, it's not a final frame renderer yet. This is one of the reasons why we want it to be easy to swap out RIS with Xpu. In those scenes where you need heterogeneous volumes and there's no support for those in Xpu at the moment, you can always fall back to RIS now. We need to make sure that we're producing all the lighting AOVs to allow Xpu to be useful from providing comp the images that they need. There's lots more. I won't go into all of the details here, but we're excited to move on to these in future releases in 25 and beyond. And that's it from me. Thanks very much to the whole RenderMan team for making Xpu possible. There's been so much work done by the whole team, and without that work, Xpu would not be where it is today. There's also a talk tomorrow. My talk's been very light on content. Please go and see the Xpu talk tomorrow. There's loads of content in that. You'll be able to see Xpu being used within Flow, which is really exciting. And thank you for listening. I think the next talk is the stupid RenderMan for Houdini tricks, which is being presented by Rob PK.
Hey everyone. Hey everyone, it's great to be here and be able to talk to you about one of my latest RenderMan experiments. So, without any further ado, I introduce how to solve mazes using some ray tracing in RenderMan. First, I'm going to talk about making a maze, then solving one, and then I'm going to show you some pictures. So, making a maze is actually surprisingly simple. You start with a grid. Here I've done a 3x3 and just labeled them with the letters A through I. And kind of a list of cells that you might want to revisit. And then from here, we're going to go and knock down a bunch of walls until we have a maze that remains. So we'll start with A and add that to the list. And we look at the neighboring cells of A. In this case, we have B to the right and D down below. Now, both B and D are fully intact, and that means that they have 4 walls. They've got top, bottom, left, and right wall. And that means that we can actually knock down the wall between A and either B or D. So we'll choose D, and we'll move down to D and add D to the list. And you can see that we've knocked down the wall in between here. D can't go back to A because that wall's already been knocked down, but it can go down to G or across to E. So we'll go to E, then we'll go again, let's go to the right again over to F. We'll go up to C, and then left to B. Now, at this point, B doesn't have any intact neighbors. A is not intact because it's missing its bottom wall. E below it is not intact, and C to the right is not intact because that's where we came from. So at this point, we have to start popping items off of the list. So we're going to have to go backtracking effectively. So we go back to C, and then we go back to F. Now at this point, F does have another intact neighbor, and that's the one down below it, called I. So we'll knock down the wall down there to I. Now we can knock down some more walls over to H, and then over to G. And now G doesn't have any intact neighbors, so we have to backtrack back to H, I, F, E, D, A, and now we're kind of back at the beginning again. We have our empty list, and so our maze is complete. And the only thing that remains at this point is to just pick a starting and ending cell and kind of just mark off or erase some of the walls there. So now we know where to start and exit the maze. Now, in terms of actually generating geometry from this, if this was any other year, I would do this as a RenderMan procedural. But it's not any other year. I recently joined a company who pride themselves on creating procedural software, and so let's give that a try instead. One moment, get to my desktop and wait for Houdini to launch. Okay, so here we are inside of Houdini, specifically inside of Solaris. So let's go ahead and build a maze using USD geometry. So the first thing we need is, of course, our maze generation. Got a little Python script that does that, and that generates this point cloud you can see here in the viewport, where each of these little dots is going to be turned into a wall, either kind of a side wall or a top-bottom wall. The next thing we need is, of course, a piece of wall, so highly exciting, box here, R&D Programmer Art. And then we're going to go and instance those together. So now we've got the points coming in on one side, the wall coming in on the other side, and voila, we've got the maze that we generated before. Let's just flesh out the scene just a little bit more with a ground plane and some nice sky lighting. Now we can go and explore this a little bit. So we can generate lots of different kinds of mazes, lots of different styles of mazes just by changing the random number generator. Maybe not that many different styles for a 3x3 maze. But let's go and actually make this thing quite a bit bigger. And let's also switch over to some nicer rendering. Use RenderMan, pull back a little bit more. And we'll also just make the wall a little bit kind of more contrasty. There we go. Now we can start to see everything. And voila, we have a maze built out of USD geometry in Houdini Solaris, and of course rendered using RenderMan. So let's get this out of the way and we'll return to the presentation. Great, so now we've got a maze. Let's actually go and solve it. And as promised, we're going to use a little bit of ray tracing in RenderMan to do this. So solving a maze, got to start somewhere. Let's start at the beginning, top left in this case. The basic premise of how to solve a maze, the easiest way, is to just put your hand on the wall and never take your hand off of it. So in this case, we'll use our left hand. We'll put our left hand on the wall, to the left, which is the top wall there. And we're basically just going to trace around the maze. And when I say trace, we're going to use ray tracing. So we're going to fire 3 rays. We're going to fire one to the left, the blue one. We're going to fire one straight ahead, the green one, and we're going to fire one to the right, the red one. And we're going to look for which of these rays intersect geometry and which of them don't. And we're going to give priority to turning left, then going straight, then turning right, and eventually also just turning around as well. So there is an intersection to the left, so we're not going to turn left. There's an intersection straight ahead, so we're not going to go straight ahead. But there's no intersection to the right, so we're going to turn right. So now we're facing downwards. And we'll take a step forwards. And we'll do the same thing again. We'll fire off 3 rays to the left, straight ahead, and to the right. In this case, there is no intersection to the left, so we turn left and take a step forward. And repeat again. So we can move forwards, we can turn left, and now we're stuck. All 3 of these rays are going to generate intersections. So we turn around and go backwards. Now we can turn right, we can go straight, and we can turn left, and we're out of the maze. And that's how it's done. So let's go back to Houdini and Solaris. We've got the maze that we had before here. You can see it here on the left, and the node graph that created it. Now, to solve the maze, we're going to have to add a few more nodes. So the first thing we're going to do is to add some geometry, which is going to represent the solved path. And it's basically just a quad that covers the maze. And we're going to start with it just colored yellow here. Now, the interesting bit is a custom pattern node, Rix Maze Solver, that we're going to apply to the grid. And what this pattern actually does is to effectively freeze the renderer as soon as the first pixel of this yellow quad is rendered. It just kind of locks the overall state. And then goes and solves the maze. And it does this by creating kind of a phantom origin here at the start, firing off the rays as I showed how to do to solve a maze, and kind of working out what the path is as it meanders its way through, creating new origins, firing new rays, so on and so forth, until eventually it gets to the end here. Then it's going to store that path into memory, unlock the renderer, and continue on. When it actually then renders the rest of this yellow quad, it is going to use that saved path to drive a mask, showing where it should still be yellow and where it should be transparent. So if we go further down here to the end, we can see that there is our completed path as it weaves its way through the maze. Now, one of the interesting things about this shader is that there's a max steps parameter that we can control. So rather than solving the maze to completion, we can, for example, drive this off of the current frame number. So on frame 1, we only take 1 step through the maze. And on frame 39, we take 39 steps through the maze. So we can just kind of scrub through and watch this thing work its way through. Here it is kind of at the top. Kind of took a wrong turn somewhere, and now it's way over here. And as we keep scrubbing through, we eventually find that it finishes the maze at around 470. Yeah, around frame 470 is when it ends up finishing the maze. So yeah, that's how we actually end up rendering a path, a maze solution, using RenderMan and custom Rix maze solver pattern. So what kind of mazes can we make? Well, here's a little garden maze made out of fences, and we can see the solver do its thing. There we go. Now here's a slightly bigger maze made out of dominoes, and being a bigger maze, it's going to take a little bit longer to solve. So let's zip forward through time here. Almost there. Almost there, and done. But of course, everyone knows the best mazes are hedge mazes, such as this walking teapot hedge maze. It's truly amazing. And on that note, I think it's time for me to sign off. Thanks everyone, hope you enjoyed.
Hello everyone, my name is Mark Manka and I'm a part of the RenderMan product management team. I will be facilitating a live conversation and Q&A session about RenderMan and its companion technologies with a group of panelists from across the team. But first, a big thank you to Rob and all of our presenters, and a huge thank you to the RenderMan team. None of this would be possible without their hard work. So panelists, can you please come on stage? To those of you in the live audience, please feel free to submit your questions into the questions tab of your Livestorm session. We'll be answering as many of them as we can live. But before we dive in, let's do a round of introductions. Oliver, can you kick us off and reintroduce yourself?
Sure. Hey, my name is Oliver Margaret, Vice President for the Renderman Group. Yeah.
Excellent. Wayne, can you introduce yourself, followed by Philippe?
Yes, my name is Wayne Wooten, and I'm the Software Development Manager for the RenderMan Products Group.
My name is Philippe Laprince, and I am a RenderMan Field Engineer.
Excellent, thanks. Spiff, you're next, and then wrapping up with Per and Mark.
Hi, I'm Sebastian Gracia. Everybody knows me as Spiff. I am the lead engineer for the USD team at Pixar.
Hi, my name is Per Christensen. I'm a principal software developer in the RenderMan team.
I'm Mark Brennesser. I'm an engineering lead for the Xpu project.
Excellent. Thanks, everyone. All right, let's go ahead and get started. And again, reminder to type in your questions into the questions tab. I'm just going to dive in and get the conversation started with Oliver. Now, you know, Flow looks pretty awesome. Is it going to be made available to artists outside of Pixar?
It will not. So Flow right now is our internal tool and is developed in a way that it works with the Pixar pipeline perfectly. And we not have any intention right now to ship it with RenderMan or make it a separate product.
Okay, cool, thanks. Spiff, we heard a little bit about USD, and USD and Hydra are constantly evolving. Like, can you speak a little bit about some of the areas where it's evolving in support of production renderers?
Sure. Production rendering is actually our #1 focus, has been for at least the last 6 months and ongoing. One of the key things we're working on right now is filling out our support for RenderMan concepts and plugins so that they can be represented and edited in USD. For those familiar with it, this will be extensions to the USD render settings that we discussed publicly last year. And we are also majorly redesigning the Hydra architecture to better support more fully transferring render settings, and also to be able to do what we call scene filtering. These are filtering operations, modifications that are often necessary to make on the way to a final frame render. That is kind of a long dev project right now. We're in the design phases right now. In addition to that, we're working on several USD enhancements for the pipeline developers out there. We are majorly reworking our AR asset resolver system right now to make it easier and more comprehensible to plug in your own resolver, and also to be able to have multiple resolvers active at once, which will make it much easier to integrate your own behavior into DCCs and just overall make things more flexible. And finally, to make it possible to not just read, but also write non-file-based assets. So for working with assets that come from the cloud, transmitted over networks, other things like that. There's much more going on, but I'll cap it at that for now, since we only have a limited amount of time.
Thank you. And I'll just plug the USD interest Google group for those that are interested. There's a lot of kind of interesting conversation that goes on there. Wayne, I think we'll stick with the theme of USD for now. Spiff talked a little bit about the bridge products. Can you kind of add your 2 cents about the best ways to work, combine RenderMan and USD usage inside of bridge products?
Yeah, certainly. Certainly one of the best ways to utilize USD was demonstrated by Rob PK and this stupid RenderMan for Houdini trick. Houdini provides a product called Solaris, and Solaris provides a direct interface to both USD as a concept of scene data, as well as a Hydra interface to allow you to render directly to RenderMan, both interactively and in batch. And so you can compose your scenes with USD assets. You can then apply materials and lights to those scenes. You can interactively preview while you're setting those scenes up, and then you can submit those scenes for batch rendering. And we continue to evolve Solaris as Side Effects continues to add new features as well. And also we continue to embrace all the great improvements the USD team is making to the product as well.
Cool, thank you. Philippe, this next one's going to be for you. This question comes from Nicholas. Can you speak more to material layering, the difference between horizontal and vertical layering, most specifically? And then also, can you compare it a bit to the old way of blending BXDFs?
Okay. So previously, what we were doing, we were not blending BXDFs. So we were not blending the individual lobes together. What we were doing, we were blending the pattern signals that were the input to the BXDFs. So in practice, it looks good most of the time, but there are some limitations in terms of what you can achieve. And we figured that it's more accurate to be able to mix the lobes together, to blend them or to layer them. In the case of Llama Mix, which is the horizontal layering option, and if you ever get a look at the Materialx definition, you will see they have the same terminology. So horizontal layering is basically allowing you to blend between two materials. So it's like a mix. You can choose more of one or blend them, and you can use a mask, of course, to have a spatial definition of that blend. So any texture or pattern can be used to do that. And in that case, it's just kind of it looks a lot like the over operation in a compositing software. The other one, which is the vertical option, Llama Stack, has at the core this idea that you have a substrate, the base material, and then you have a layer on top of that, and that layer has a thickness. And typically, this is what we had in Pixar surface with the clear coat. So the clear coat had a roughness, and if you had put like a transmission color in the clear coat, then you would be able to compute the extension of that clear coat using Beer's law. So Llama Stack allows you to do that. And the beauty of the system is that at some point in the future, when we get better layering algorithms, we can just write a node that will do that. So I think it's a very open solution, and that will allow us to iterate for a good while.
Cool, thanks, Philippe. Mark, this next one is for you. This one comes from Chris. He's basically asking about minimum GPU requirements and what we would recommend for people.
The minimum GPU requirements that we're targeting at the moment are is the Maxwell architecture. So we're not going any older than that for NVIDIA. We're fully supporting the Quadro lineup. But in principle, Xpu should run on any sort of NVIDIA hardware using the Maxwell architecture or above. So that's mainly going to be the focus. Key thing I didn't mention actually is that the Xpu as a renderer, the GPU backend is CUDA based. That's predominantly, totally NVIDIA GPUs. But we also have optic support within it, and that allows us to use the latest NVIDIA ray tracing hardware on machines that have it. So we do leverage that when it's available. And newer micro architectures come in that have more powerful ray tracing hardware, we should be able to use those as well. So I'd focus on those. We're not today. We haven't written a backend for AMD. That's something we've discussed as a group for a while now, and there is something in the pipeline there, but it's just not coming as quickly as people would like, I imagine. So certainly for 24, we're looking at Maxwell and above on NVIDIA hardware specifically.
Okay, cool. Thank you. This next question is for Oliver. We've had kind of several questions related to integrations to RenderMan to products that are not Maya and Katana and Houdini. Can you talk a little bit about our strategy for bridge products and when it may make sense to bring support for additional products into the portfolio?
Sure. I mean, we're totally driven by customer demand, and I mean, we're looking at tools that are requested by our customers first, and that's the reason why Blender is also on the list right now to be released. So I saw there's quite a few questions coming up about C40 development, and it's obviously something we would like to do. And it is on the list, but there is no timeline yet, and no real active project at this point. But we're looking at more DCCs once it becomes more relevant. And also the latest question I see from Diego about Unreal and RenderMan. I mean, it's something we can think about in the future as well, as the market's going to change right now. But we're going to focus on the main DCCs for now and try to make careful steps towards additional DCCs.
Thanks, Oliver. Philippe, this next one is for you. We've had several questions about Materialx and Llama. Can you talk a little bit about those two technologies and kind of what it might mean for the future?
Sure. So ILM developed Llama with the idea that it should align with Materialx. So you know that ILM and Autodesk have been collaborating for a while on the definition of the materials, the BXDFs. So what are the different lobes? How are they combined? How are we going to describe them through Materialx? So Llama is compatible with those descriptions. Now what we can do is, of course, it's something we haven't done yet, but that's definitely on our list, is to allow people to import and export Materialx documents and then transform them into Maya network, Llama network, sorry, that will replicate the look thereafter. So that includes, bespoke materials, and also, more standard things like the standard surface that Autodesk is pushing for. So all those things are possible, but you need to bear in mind that USD is coming into the mix as well. And as presented recently during SIGGRAPH, there is an initiative to kind of make USD and Materialx compatible. So we are trying to, we are going to try to shoot for this solution that would answer those two sides of the equation, where we would have a way that is compatible with Materialx and USD. I think it needs to be a long-term solution, because people have been told that they would be able to exchange material easily for a long time, and it's a really complex issue, and we need a way to make sure that those two standards are not, incompatible, and work for the artists.
Well, thanks, Philippe. This next one's for Per. Per, can you give us a brief summary of the blue noise properties? It was mentioned briefly in Dylan's presentation, and it'd be interesting to get your perspective on that, and then how that may or may not affect adaptive sampling.
Sure, yes. So in RenderMan, we have sample sequences that we call progressive multi-jittered. And we continue to use those, so have good stratification properties, low error, good convergence. But in addition, there was a wonderful SIGGRAPH talk last year, and it was about the blue noise. So basically, it's a way of improving these sample sequences in a way that in the first iterations, they look much more pleasing to the eye. So in a strictly mathematical sense, what you see, if you measure it, will actually not be measurable better, but visually, it looks a lot better. And the way that works is that it's basically coordinating the sample sequences between neighboring pixels. So you get a guarantee that you have, if you have a certain error in one pixel, then the next pixel over will compensate for that in some sense. It's a lot easier to describe with pictures, which I'll do on Thursday in the session at noon. But the main take-home message is just that you're kind of getting something for free. You're looking, let's say you're interactively rendering, and you're moving your objects around, you're changing your scene. So what you're looking at is most of the time something with a very low sample count, and that's where this improvement really kicks in. It's much more visually pleasing to look at those low sample counts.
Nice, thank you. And then can you describe, is blue noise going to be available in Xpu, and will adaptive sampling be available in Xpu?
Okay, so yes, so the blue noise is both in Xpu and RIS, so that's already built in. For adaptive sampling, so currently we have only adaptive sampling in RIS. It's not yet in Xpu, but it's something on the to-do list. So it's quite possible that maybe for release 25 we might have adaptive sampling in Xpu.
Okay, cool. Thank you. Wayne, this one is for you. Rory asked the question, what is a recommended way to go about look developing assets in RenderMan pipelines that will also be used in a real-time engine like Unreal or Unity for virtual production?
Well, there's a number of different ways to go about doing it. So the recommended way, I would recommend utilizing USD for such a, a pipeline. And, that's under the assumption that Unity and Unreal have reasonable USD ingestion, which, I'm under the impression that they actually do have pretty reasonable USD workflows. And so it's fairly easy to generate look dev workflows in Houdini or Solaris, or even in tools coming out in the near future. Future versions of both Maya and Katana are starting to embrace USD workflows. So you can choose your kind of look dev workflow of choice, what you're most comfortable working in terms of creating the look for your objects. And then, of course, you will have to convert your textures over to formats that would be, acceptable for those products. The RenderMan texture format is not compatible, for instance, with the, Unreal Engine texture format. Usually, for these more real-time workflows, you have a more compressed, lossy texture conversion pass. But once you've converted over all your textures and, you utilize a common look, USD preview surface is a great one. And as a matter of fact, we use that to create the augmented reality Teapot. USDZ files are great for that type of workflow as well. So it's not really a definite recommended way of doing it, but just some things to look out for when you are doing it.
Okay, sounds good. Mark, this is a question for you. I'm going to kind of take Nicholas's question and tweak it a little bit. There's this notion of writing shaders for flow, kind of native to RTP versus the patterns and BXDFs that are used in RenderMan, whether it be Katana or some other bridge product. Is that kind of thing going to be necessary for XPU? Like, are people going to need to write two different sets of patterns or BXDFs to run in either renderer?
So if let's talk about patterns first. Patterns are supported in XPU with, we support OSL natively inside XPU. And RES also supports OSL natively. So the idea is that as long as clients are using OSL to write their patterns, or they use the OSL patterns that we provide with RenderMan 24, then those will just work naturally in both renderers. So there's nothing to do there. The light transport plugins are, we're keeping those, the interface to those locked down in XPU for the 24 product life cycle as we, at least initially, as we develop the APIs to make sure that they are sufficiently stable to release to clients, which means that the BXDFs that we provide, we will make sure match with the same BXDFs in RES. But any client-written BXDFs for RES, clients will have difficulty implementing a similar one in XPU initially. That's not, it is a plugin architecture. So we do support BXDF plugins. That's how the internal plugins are written, integrators as well. They're not dissimilar from RES. So in principle, we can open up this interface if necessary, or in the future. And we certainly intend to. The plugin interface that we do support at the moment is for the display plugins. So the intention is that any output, so some of our display drivers, EXR, TIFF, and the image tool display drivers are already implemented and support both XPU and RES. And I can't see any reason why we wouldn't make that API available for clients as well to support their own image tools.
Nice, thank you. I'm going to take the second half of Nicholas's question and answer, or ask you to answer that as well. So during the presentations, both from Dylan and yourself, we talked about XPU really being focused as a interactive look development renderer for RenderMan 24 that's predictive of RIS. But Nicholas also asks, would it also be possible to light with Xpu and RenderMan 24?
Yes, yes. One of the areas that we haven't spent any time on really is scalability, is lighting scalability. So provided you have scenes with few light sources, then you can absolutely light an XPU. But I haven't tried it with a million light sources. I can't imagine it would be too pretty right now. But that's certainly a feature that we intend for future releases, 25 or beyond.
Yeah. We're not going to recommend lighting Cocoa quite yet with XPU. That's for sure. Lighting is kind of a broad topic, so I'll just maybe ask a follow-up question for Nicholas. There's also lighting can also mean giving AOVs and other kind of artifacts over to comp. Does XPU support that now?
No, probably not. No, I mentioned that in the presentation. Not the full set of AOVs that I think comp departments would expect. That's definitely a feature for 25. There's a lot of background to that I won't go into LPEs specifically. At least not comp departments of medium to big studios. So we haven't focused XPU around that workflow at all. We've been very much focused on look development and shader edits. So that's definitely something to be aware of as you try XPU and RenderMan 24.
Okay, cool. Thank you. This would be a question for Spiff. Spiff, there's been a couple questions around some of the specifics about USD. In particular, one about exporting character rigs. Is that something that the team is thinking about?
Exporting character rigs is not something that we have plans in any time in the near future to incorporate as part of the USD standard. In particular, because as you know, when we add something to USD, we try really hard to also provide an implementation for it such that you can get the same behavior everywhere. Rigging is pretty difficult to do that with, and to be able to support kind of a universal rigging system would mean also providing a universal execution system to execute those rigs efficiently. That's not something we're prepared to do at this time. That said, we believe that USD has kind of the fundamentals for other people to be able to create their own schemas and export rigs from other packages into USD and re-import them. I think it was 3 or 4 years ago that I believe it was Ubisoft actually was saving out Maya rigs in USD and re-importing them back, which was pretty impressive. It was before USD had quite all the representational capabilities it has now. But people should feel free to encode rigs in USD for their internal pipelines, if that would be useful.
Cool, thanks, Biff. Philippe, this one is for you. This one comes from Eric, and the question is, essentially, Llama materials are still using the specular roughness path, at least it looks like from the presentation. He asks, or she asks, because so many other applications have been moving to metallic and gloss. Can you talk a bit about that?
Okay, so it looks like a lot of VFX companies who are doing high-end are not using metallic, as far as I know, and ILM isn't. So there's a number of reasons for that, because the metallic system assumes a combination of lobes, and Llama doesn't assume any combination of lobes. You can do your own, but if that makes things easier for you, I can write a little pattern in probably a couple of hours that will allow you to basically plug a metallic map and output to the correct values to your diffuse and specular. That's something I already did for the Substance plugin. So basically, I created a couple of blend nodes to take the metallic map and turn it into a specular and a diffuse contribution. So it's it's nothing to do.
Cool. Well, maybe we'll see what we can do, I guess, is the summary of that question. Wayne, this next one is for you. Volumes have a bit of a sordid past in RenderMan. Sometimes they render really quick, other times, less than amazing. Do we have any plans to improve performance with rendering volumes in RAS, especially when they're motion blurred?
Indeed. So volumes are interesting in RenderMan. We get everything from the volumes in RenderMan are the best ever to the volumes in RenderMan are the worst ever. So it's fun to get both sides of the coin there. However, with motion blur, RenderMan consumes a lot of memory when rendering volumes and renders them fairly slowly. And we're actively working on significant improvements to both the memory footprint and the amount of render time required when rendering especially high-speed volumes. So volumes where you're feeding a velocity vector in your VDB alongside the density or other fields in your VDB. So yeah, we hear folks on that, and we're actively working to improve it.
Well, thanks, Wayne. That's always good news. Extra performance, no matter where it is always a good thing. Excellent. Next one is a question from Victor. Basically, he's trying to understand if Llama is going to be the new standard recommended surface material for RenderMan, or is it just an additional shader that will benefit certain use cases, but Pixar Surface is still the primary recommended shader?
So Pixar Surface, I think, is not going away, at least not in 24. But we think that Llama is a lot more, forward-looking because it will tie in with USD and Materialx, and it's not as easy to do that with Pixar Surface. So I would say, if you like Pixar Surface and it works for you, that's fine. But I guess at some point, Llama may take over. It's possible. It's a possibility.
Yeah, cool. Thanks, Philippe. This one we'll hand off to Wayne, although it is also in the subject of Llama, but just to balance a little bit. Will Llama have preview shaders for Substance and Mari?
Well, that's actually a better question for Philippe, but I think, Philippe, correct me if I'm wrong, you've already implemented Llama preview shaders for Mari. I'm not sure of the status currently of the Substance shaders.
So we have the bricks to build the Mari system. It's not done yet. So I think it might arrive in adult release because I'm not sure we're going to have time to do this. But once we have that, it shouldn't be too difficult to make the Substance part as well. The thing you need to understand is that you will have to define your network somehow before starting your Mari session, because we need to bake a GLSL shader, or at least a number of GLSL fragments that will represent the look of the Llama material inside the Mari. Mari is not designed to be modular. So, well, it is designed to be modular, but not in that area. So there will be a couple of constraints, but it should, that's basically what ILM has been using for the last couple of years. So I'm fairly confident it's going to work all right.
Yeah, and we have a good relationship with the Foundry. I mean, we were able to get, preview shaders for PXR, most of the aspects of PXR Surface into Mari, and if we send them updates for Llama, I'm sure we can get those into Mari as well. So,
yeah.
One interesting thing about Llama is that you can actually recreate, other other monolithic BXDFs from it. You know, Philippe mentioned this point, but you know, you could create a metallic style BXDF, or you could create a new Pixar Disney, or you could even recreate Pixar Service, or even the Arnold AI standard BXDFs. All of those can be created from the basic building blocks of Llama. And
yeah, I think
that's
this is
where its power shows.
I think that's something that we will provide as presets from the preset browser, so that people can start with, you know, predefined Llama network.
Cool, thanks both of you. Philippe, we're just going to stick with Llama. It's a popular topic in the Q&A session. Eric asks, can you talk a little bit about displacement layering using Llama?
At the moment, there is nothing really new in terms of displacement layering, because displacement is really a completely separate phase in our rendering pipeline. You know, basically, the displacement bakes the geometry into, you know, a different shape, and then that's what we light. So we could make it look as if you have this kind of layering thing, because now the renderer is interactive and you can change the displacement on the fly, but it's not something we have focused on for the time being.
Okay, cool, thank you. Philippe, this is going to be another one for you. Ricardo asks, not related to Llama, but definitely in your wheelhouse. Any chance to see in the future of RenderMan the use of SPD on lights and measured CRF on cameras to enhance lighting compositing?
It's a possibility, indeed.
Okay, yeah, good answer. I like that one. Okay, let's go ahead and get to another question here. It's kind of searching through the list. Oliver, can you talk, I'm giving Oliver all the hard questions here. Can you talk a little bit about the stylized looks with RenderMan and the commercial versus non-commercial release?
Sure. So yeah, that will be actually something new when we're going to ship 24. That stylized looks will be completely available in the commercial version of RenderMan, but not in the NCR version of RenderMan. It's a co-development with external partners in order to really deliver the best tech possible to you. And so there's some limitations why we can't ship it in the non-commercial version of RenderMan.
Okay, cool. Thanks, Oliver. Mark, can you tell us a little bit about the hardware that XPU requires? And that's going to kind of be a leading question to the question about the Macintosh and XPU.
Okay. Yeah, I mean, XPU's backend, as I mentioned just a moment ago, is NVIDIA focused. And it also uses the CPUs as well. From a GPU point of view, it's NVIDIA focused. Right now, the one implementation that we do have, there is memory constraints are different on GPUs than they are on CPUs. They're kind of harder operating systems that give you some flexibility that make the limit sort of more soft. It's difficult to describe this, but ultimately there's a memory cliff on GPUs. Once you hit it, you just fail entirely. We have texture paging, which is an absolute necessity in any sort of non-toy renderer, which helps us deal with large production assets. We spend a lot of time compressing geometry. We've concentrated on compression in a lot of our pipeline in the hope that we can render some pretty big sets on low memory GPUs. That said, there's no real bottom end limit. There is a limit. We will come out with a minimum specification for this. There is a limit where you need a certain amount of memory to run the renderer. But beyond there, it's really about content. So you should in principle be able to render some very small assets with smaller GPUs. But as you sort of go up in complexity in what you're trying to render with XPU, you'll need more and more memory for this. having said all of that, one of the points of Xpu is that you can always switch to using the CPU version of Xpu. So if you're limited in GPU memory, you always have the CPU as kind of a backup plan, or rather a fallback, really, I should say. So you will at least be able to get a render out. We spent a lot of time on team. Well, it's absolutely essential if you think about it. If you have both the CPU and the GPU contributing to the same image, which is absolutely something we support in XPU, you need to make sure that both backends are producing exactly the same result or near enough within some numerical tolerance, which is what we've done. So you can be confident that you get the same image with just using the CPU as just using the GPU and using both at the same time. But yeah, the minimum spec in terms of memory is we should be able to support a large set of cards these days, NVIDIA specific. So moving on to Mac though, there's no direct plan, I think, at the moment in terms of schedule for delivering on Mac. I have been talking with developers from other hardware companies over the last year to sort of figure out how we might do that. I think the takeaway for me is that the architecture is and the design of XPU is largely in place to facilitate easy transition to new hardware vendors. There's some important questions that we need to answer that are mainly focused around OSL and the support for OSL. And that's the most difficult problem when it comes to undertaking some new hardware. But the vendors seem pretty keen on this as a project from their point of view. I think that's all I can say, really.
Thanks, Mark. Thank you. I think we only have time for one more question. We have about a minute, minute and a half for the answer. This one comes from Remy, and this is for you, Oliver. Can you tell me why RenderMan would be your render engine of choice versus other vendors, and why do you feel, or what do you feel you do best?
Well, that's a tough one. I think rendering is almost a religion by now, but I think we're focusing obviously on the most important pieces. One is obviously performance, but also, as you expected from our movies, we need to scale. So our artists at the studio building massive scenes, so we need a design system that can scale to any type of production. Or even if we look at our customers like MPC or ILM, those scenes can become even bigger. So we always try to match or try to find a good match between like performance and scalability. On the other side, also focusing on stability and design a system that's very open, so TDs can also access the system in various parts of the pipeline to interfere with the rendering. And also just want to pick up one question briefly from Jennifer asking about statistics. So the statistics system is also exactly that. It's something where we want to capture live statistics coming out of the renderer so we can identify what's going on in the engine. So it's debuggable at any point in time. And it will be, so the initial idea right now is to have a separate interface that you can access all the data, and you can also build your own listeners to watch your rendering process. And I think we try to be even fairly open with the engine itself and not try to hide anything from the user. So I think this is what makes RenderMan so different. And I mean, the look is also something that is very important to us. And so Xpu is designed with like maintaining the look between even different devices. And so that's yeah, a key philosophy on RenderMan.
Cool, thank you, Oliver. With that, we are unfortunately at time. In closing, I, on behalf of the RenderMan team, thank you all for spending an hour and a half with us today. We really hope you enjoyed it. Don't forget to register for additional sessions taking place tomorrow and Thursday. Statistics is going to get a nice focus on Thursday. XPU gets focused tomorrow. There's a lot of sessions coming up, so please click the button that's now on your screen to register for additional sessions. And then don't forget to post a picture of your teapots. Like I personally cannot wait to see what people do, with their virtual teapot. So see you all next time. Thank you for coming. and we hope you enjoyed it.
Thank you.